Hello children, welcome to Math Park. Our today's topic is compound interest and exponential growth and decay. So let us understand what is exponential growth and decay and solve the problems on compound interest. So compound interest is the interest. We have already seen plenty of videos on this. The amount at the end of the first year becomes the principal for the next year. So if $P is invested at the rate of R% per year compound interest, then the value of the investment, which we call also as an amount, value of an investment after n years is given by the compound interest formula by P times 1 plus R by 100 raised to n. Let's solve one problem here. Adam invests $500 at a rate of 1.8% per year compound interest. Calculate the amount Adam has after 12 years. Give your answers in dollars, correct to nearest cent. So here the amount that is investment principal is $500. So we take this as P is equal to $500. The rate of interest is 1.8% and the number of years is 12. Put in the formula. So we have 500 times 1 plus 1.8 upon 100. So taking the LCM here, we get 100, we get it as 500 times 1.18. 500 times 1.18 to the power 12. Okay, so 100. So it is going to be 118 by 100, which becomes 1.18 to the power 12. Put in your calculator 500 times 1.18 to the power 12, which we get it as dollar 3,643 and 80 paisa to the nearest cents. We get the 799 something, which we round up to 80 cents. Got it? Next question. Amelia invests $800 for 7 years at a rate of R% interest, compound interest. At the end of 7 years, she has the total of dollar 1,243 and 19 cents. So this is going to be your value of an investment, which we call as an amount. The number of years is 7, n is equal to 7. The rate of interest is what we have to calculate. So let us put the values in the value of investment P times 1 plus R by 100 raised to n. Let us take here the P is 800, 1 plus R by 100 raised to 7. Now dividing by 800 throughout, dividing by 800 on both ends, we get the value as 1.5539 and is equal to 1 plus R by 100 raised to 7. Now take the seventh root on both sides. So taking the seventh root on both sides, seventh root of 1.5539 in your calculator, we get it as 1.065. Subtracting 1 from both ends, 1 minus 0.065 minus 1, we get it as 0.065 is equal to R by 100. And then multiplying by 100 on both ends. We multiply by 100 on both ends. We get this as 6.5%. So rate of interest is 6.5%. Got it? Farhat and Mustafa both invest $5,000. Both of them are investing $5,000. Farhat invests her rupees 5,000 in a bank that pays X% per year simple interest. Mustafa invests $5,000 at a rate of 3% per year compound interest. After 10 years, their investment are worth the same amount. That means their amount is same that which they are getting after 10 years. We have to find out the X, that is the percentage for which Farhat has invested. So for Farhat, the amount that he is going to get is principal plus interest. This is your principal plus interest. So interest is 500 times x by 100. So we know that the simple interest formula, it is P times R times T by 100. So principal into rate into time. Rate is x. This is for Farhad. And for Mustafa, it is P bracket 1 plus, this is the amount. Amount is equal to this. Amount for Mustafa is equal to P bracket 1 plus R by 100 raised to N. Let us simplify. The amount that Farhad gets is equal to amount that Mustafa gets. So equating, we get this equation. Now let us simplify. Divide both the sides by 5,000. When you divide both the sides by 5,000, each term we are dividing. So when we are dividing each term, this 5,000 is going to get cancelled. This 5,000 upon 5,000. So, and this 5,000 is going to get cancelled. So, this is how the next statement we get it as 1. So, 5,000 upon 5,000 is 1. So, this is x upon 10 is 0.1x, and this 5,000 got cancelled. 100 plus 3 is 103. 103 by 100 is 1.03 to the power 10. 03 to the power 10 is 1.3439. And now let us subtract 1 from both ends. We get it as 0.1 x is equal to 1.3439 minus 1, which becomes 0.3439. Now we have 0.1 here. So what we do here is dividing by uh, 0.1, which is same as 10 here. You get x is equal to 3.44, correct to 3 significant figures. So it is going to be 3.439. So which we get it as 3.44 to the, so 3.44% is the rate of interest at which Farhat has invested. Got it? Now, exponential growth and decay. So when the growth rate of an exponential function is positive, it is called exponential growth. When it is positive, it is called exponential growth. And some possible examples of exponential growth are like value of an investment. When we invest the money in the bank, it grows, it increases. Population of growth, bacteria growth, or number of vehicles which are increasing, increase in number of vehicles. That is again example of exponential growth. What is exponential decay? So when the growth rate of an exponential function is negative, it is called an exponential decay. So some possible examples are population decrease, the value of the car depreciates. So that is again exponential decay, radioactive decay, temperature cooling is again the example of exponential decay. Let's start solving some problems here. So we have the same formula, similar like that, but here we write it as x0. So the formula that is used for solving exponential growth and decay problems is final value is equal to x0 times 1 plus r by 100 to the power n, where x0 is the initial value, r is the rate of growth, and n is the time interval. Okay, it could be in hours, it could be in months, whatever. For exponential growth, remember the r is greater than 0, and for exponential decay, r is less than 0. So we have a question here. At the start of an experiment, there are 2,000 bacteria. The number of bacteria increase at the rate of 18% per hour. You can see that r is greater than 0, rate 18% per hour. Work out the number of bacteria after 6 hours. So we have the initial count of bacteria. Let us use the formula here. Number of bacteria is x0 times 1 plus r by 100 to the power n. So x0 is 2000, r rate of growth is 18%, and n is 6 hours. Let us put the values here. So 2000 times 1 plus 18 by 100 to the power 6. 18 by 100, so it is 118 by 100. So 1.18 to the power 6. 2000 times 1.18 to the power 6, we get it as 5399.1, and it continues. So rounding it to the round figure, we get this as 5400, 5400 bacteria. You can say correct to 2 significant figures. This is correct to 2 significant figures. Got it? Rounding up to the whole number, we get this as 5400 bacteria will be there after 6 hours. Ben buys a car for $7,500. Each year, the value of the car decreases by 12% of its value at the beginning of that year. Find the value of the car after 5 years. So it is decreasing. So we have value of after 5 years, it is 1 plus r by 100 to the power n. Now, since it is decreasing, we are going to take r is equal to minus 12 over here. Okay, so r is less than 0 for exponential decay. N is equal to 5 and p is 7,500. Let us put the value 7,500. So 100 minus 12, it is 88 by 100. So this is going to be 88 by 100 to the power 5. So which is 0.88 to the power 5. 7,500 times 0.88 to the power 5 in your calculator gives you $3,957.99. So this is going to be the value of the car after 5 years when the rate of depreciation is 12% per annum. Share with your friends. And if you are new to the channel, please subscribe. Thank you for watching. Have a good day.